Okay, so we want to compute the line integral of this vector field around C. C is the boundary of z equals 4 minus x squared minus y squared above the xy plane oriented outward. So this surface is a downward facing parabola or paraboloid. Okay, and we want to do this line integral, and the idea is that we want to use Stokes theorem. Okay, so there are a couple of ways to do this. Remember, the idea Stokes theorem says is that this is equal to the integral over S of the curl of F ds. Okay, so how do we do this? Well, one step is, so we'll do it the sort of straightforward way. That's not the best way. So here S is going to be this part of the paraboloid. So a parameterization for this paraboloid, I'm just going to do the cylindrical coordinates. So this is theta t. This is equal to r, sorry, I'm using t. So this is t cosine theta, t sine theta, 4 minus t squared. And then theta goes between 0 and 2 pi. All right, and then when z is equal to 0, this becomes 0 equals 4 minus x squared minus y squared. So then t goes from 0 to 2. Okay, and so now the curl of F okay, so the curl of F, well, the first component I'll let you see is equal to 0. Similarly, the second component is equal to 0. And finally, the last component is equal to minus 2, minus 2. Or this is just equal to 0, 0, minus 4. Okay, that is the curl of F. So then the next thing that we need to do is to compute r theta cross rt. Okay, so this is, you might have remembered what this is. That's fine. You can just fast forward, but I didn't. So r theta is minus t sine theta t cosine theta 0, and rt is cosine theta sine theta minus 2t. Okay, so this is equal to, okay, so the first component is going to be minus 2t squared cosine theta. The next component is going to be minus 2t squared sine theta, and the final component is going to be minus t. Okay, so is this the right pointing vector? And it's not, because we want the outward pointing normal vector. So this means the z component needs to be negative, or sorry, needs to be positive, and the z component here is negative. So the normal vector that we need is minus 1 times this. Okay, so now we're looking at the surface integral. The parameter domain is this parameter domain here. So this is theta equals 0 to 2 pi. T equals 0 to 2. The curl of F is 0, 0, minus 4. And now we dot this with in our case, it'll be RT cross R theta. So this is 2t squared cosine theta, 2t squared sine theta t dt d theta. Okay, well, all we're left with is the integral theta equals 0 to 2 pi, t equals 0 to 2, minus 4t dt d theta. Okay, and what is this? This is minus 8 pi times the integral of t from t equals 0 to t is equal to 2. The antiderivative of t is 1/2. t squared. So this is going to be 4/2. So this is going to be times 2. So this is equal to minus 16 pi. Okay, so this was one way to do this problem, where the surface that we're given is the surface z equals 4 minus x squared minus y squared above the xy plane oriented outward. In the next video, I'm going to give another way to do this problem that I think you will prefer.